Hi everybody, this is our week 6 video for Betsy Roslin and Mike Reisman. Mike's not here tonight, so I'll do it myself. This is the analysis of a bimodal network of the Davis Southern Club women. The data was given to us along with some code that we used to import the network and do some basic analysis. So the first thing was the bi-adjacency matrix, which I'm still not quite sure what we're supposed to be understanding from that. But moving along, we analyzed the women, which are the first type of node, by degrees and by weights. And you can see there's not such a huge range in the degrees, but when you look at the weights, there's a much larger range, with Teresa Anderson being clearly the most influential member of the clubs. The women are pretty well spread out over that range, though, so, there's not like a huge empty space anywhere in there. They're really pretty spread out between the 14 and 57. So then we graphed just the women, and you can see here the sort of more influential women in the middle with the heavier, thicker weighted lines. But I think the circular layout actually does a better job of showing where the more influential women are. You can see there's one click over here. These women tend to be connected to each other more heavily, and then another separate kind of click of more influential women over here. So I think that was a better choice for that graph, that layout. Then we did the same thing for the clubs. The degrees, there's really only 8 or 13, so we clearly have these 4 that are more connected than the rest of the clubs. But again, once we analyze the weights, there's clearly one club, E8, that's much more influential than any of the others. But again, they're pretty well evenly spread out over the range from 59 down to 13. We graphed the clubs, and again you can see the 4 top most influential clubs in the middle of the sort of bow tie shape, but you can also see E3, E5, and E12 have a lot of heavily weighted edges connecting them as well. And again, we did circular layout to see what else we could other insight we could gain from that. And the only other thing you really get out of this is that you can more easily see where there are missing connections. So like E14 is not connected to E1 through E5, and E1 is not connected to E10 through 14. And, so it's a little easier to see where there's a lack of connection in that circular layout. So then we did the bimodal graphs where it has the 2 nodes together. And you can see those 4 most influential clubs in the middle, surrounded by the ladies, with the more influential ones kind of grouped over here with the heavy weighted lines. But it's not really that easy to see what's going on with that graph. So then we tried the circular layout for this one. And here again, I think it's a little easier with the circular layout to see what's going on, see who the most influential ladies are, and see where the most influential clubs are. So let's see. Conclusions, basically Teresa Anderson, as I said before, is the most active and influential, followed by Evelyn, Brenda, Sylvia, Laura, and Nora. Who are all also very influential, but not necessarily all in the same clubs. And then there are 2 women, Flora Rice and Olivia Carlington, who are not as well connected as the rest of the ladies. And again, we had 2 kind of clusters where we had 2 separate groups of influential women. The four most influential clubs, E6, 7, 8, and 9, and the least influential are E1, 13, and 14. Teresa Anderson, the most influential of our women, attended all four of those most influential clubs, whereas the next three attended 3 out of the 4, but were each missing one of those 4 clubs. So then I found this complete bipartite graph function in Network X, so I tried that. And in this graph, the layout is a little bit nicer in that you have all the clubs in the middle with the women around, but you see like it looks like every woman is connected to every club, and it's just, I'm not really quite sure what's going on with this one, what the difference is, how the math is different, and how it calculates the edges. So I'd like to do a little more reading to try to figure out what this really means, but thought these graphs were interesting enough to add to the report anyway. All right, that's it. Thanks for watching.